Hey everybody, welcome back to part 5. Today we're going to be talking about memory versus storage in Solidity. This is a really important concept. It might trip you up in the future if you don't fully understand it. So we're going to talk about the basics of that today. And thank you guys so much for watching the video, of course. If you did find this video enjoyable, please hit that like button. It helps other developers see this information. Remember, it is such a good deal that this Solidity information is out there on YouTube for free. So thank you guys so much for watching. And if you are interested in more blockchain content, please consider subscribing to this channel. It really means a lot to me. Thank you so much, guys. So today we're talking about memory and storage keywords in Solidity. So let's think about it this way. Storage holds state variables, or variables that exist inside the contract, are on the network, and don't go away. That's what storage is. Memory variables are forgotten after whatever the memory is contained in is resolved and completed. And this is slightly cheaper because it saves in gas costs. Some miner doesn't have to transact this information, so it's going to be slightly cheaper on the network. So that is the way to think about it. Memory is temporary variables, and the storage is permanent variables that get held in state. So let us play around with this a little bit. So in our contract, we're going to use this uint256 array, and it's public and it's called uint array, right? So we're going to have this function here called happy function, and we're going to push a value with an array. This is a function of an array. It's called push. It just adds the value to an array. Arrays are dynamic in Solidity. I don't know if I said that earlier. Unless you declare a certain value, they're dynamic. So uint array.push 5, uint array.push 8. So it pushes the value 5 and 8. So here we're going to do something called uint, or the int array storage new array, or actually we should call it, uint 256 storage new array equals uint array. So we're going to set the index 0 of this new array equal to 0. So you might think, oh, this is a new array. This is going to be completely unrelated to this uint array. It shouldn't change the value. Well, actually, when you set something equal to another thing in storage, let's see what happens. Let's compile this and then deploy. Here, we can check that uint array should equal 5 and 8, but when we call happy function, what does index 0 equal? Uint 0 equals 0. So this overwrote this value here when we use the storage keyword, because new array is getting set to the same storage location as uint array, kind of overwriting it. So that's how storage works. You are putting something in storage, and obviously that overwrites it. So now let's think about memory. So you guys can probably see that memory is going to have the opposite effect. It's not going to overwrite it. It's going to be temporary. So let's compile this contract and deploy it. Now when we call happy function and then check index 0, we get 5 again. Even though this was set to new array, even this new array index 0 was set to 0, 5 still stayed because we weren't calling it in storage, we were calling it in memory, and memory gets forgotten at the end of the function. So if you don't fully understand this concept, it's okay. You'll probably get through a lot of your Solidity smart contract creating without fully understanding this. But keep in mind that there's a difference between storage and memory, and there's actually a third and fourth ones that we haven't talked about yet. But we won't talk about that in this series because they're not super relevant for beginners. But remember, storage and memory are very important to learn about, and they have unique uses. So memory, of course, saves on gas costs because it's temporary and doesn't have to be computed onto the state variables. But storage is permanent and stays in state. Cool. So thank you guys for watching. That's this for part 5, and we'll see you in part 6. See you later.